Hello, everyone, and welcome to this Smiths Interconnect webinar. My name is Katie, and I will be your Global Spec moderator. So now I would like to introduce today's presenters. So with us today, we have Kevin DeFord. Kevin is a Product Commercial Senior Manager for Smiths Interconnect. Also with us today, we have Kyle Gobble. Kyle is a Product Line Manager with Smiths Interconnect. So now I would like to go over today's agenda. So today we will focus on solderless SMPs and their flexibility for board-to-board connections. So we're going to start with an introduction to the SMPs, the history, and then what is soldered and what is solderless. Next, we're going to go into the EZiCoax solderless connect introduction. So we'll do an overview. We're going to talk about valve prop and performance. Then we're going to talk about our Interposer Solutions. Lastly, we're going to have a live Q&A session where any of your attendees can ask those questions using our Q&A window. So with that, I'd like to pass this over to Kevin and Kyle to start today's presentation. So Kevin, I'll start with you. Go right ahead.
All right. Thank you, Katie. Good morning, good afternoon, good evening, wherever you are, and thank you for your interest in our webinar today. So SMPs. So what are SMPs? SMP is an acronym for sub-miniature push-on connectors. They were developed by a company, Gilbert, in the 80s, now Gilbert Corning, and marketed as GPO or Gilbert Push-On. So there's many companies today that provide compatible SMP connectors for a variety of applications. So the connector is a three-piece assembly with two male connectors, which can be surface mount soldered or through-hole soldered to the printed circuit board. For the rest of the remainder of the webinar, I will refer to printed circuit boards as PCBs. So the connector, the male connector, is referred to as a shroud. It comes in two types, the SMP detent and the SMP smooth bore. That's shown here. So the detent style has a higher mating force and retention force, but the connectors are limited to 500 mating cycles or less. The smooth bore takes less force to mate and has a fraction of the retention force of the detent style. The female connector, shown in the upper left-hand corner there, is referred to as the bullet and completes the mating of the two connectors located on adjacent PCBs. The connectors can be blind mated, but require as much as 9 pounds force for the detent to mate a single connector. So you can imagine if you have, let's say 32 of these on a PCB, the force to mate the PCBs together would exceed 280 pounds. So SMPs are RF contacts capable of operating from DC to 40 gigahertz with low insertion loss. They're designed to be 50 ohms nominal impedance and operate between -65 and 165 degrees Celsius. They can withstand up to 325 volts RMS, and they have good leakage and shielding characteristics with better than 80 dB rejection. So as I mentioned previously, SMPs can be blind mated, but placement of the shrouds and board-to-board tolerances can lead to misalignment. So radial misalignment is when the shrouds are off true center in the X and Y direction or both. And the bullet style SMPs can absorb this type of misalignment up to about 10 mils before suffering loss of RF performance. Axial alignment is misalignment in the Z direction or the distance from board to board. The values for misalignment can vary by manufacturer. Angular misalignment is the product of radial and axial misalignment. When the shrouds are off from each other, the bullet sits in the shroud at an angle, as shown here in this image. So now we're going to talk about EZiCoax. So what is EZiCoax? So EZiCoax is a single-piece spring-loaded coax connector used for high-speed RF applications. It is double-ended with spring-loaded signal and ground contacts. Smiths is proud to introduce its new spring-loaded contact EZiCoax. It's fully encapsulated and mates between two PCBs by compression. It doesn't require any soldering and is sold in interposers that align the contacts to the PCB. Another benefit is that interposers can be designed with, need to advance that slide, can be designed with digital and power contacts to provide a total connector solution for mixed signaling applications. The smallest coax has a low profile at 3.3 millimeters board-to-board distance. That's 130 thousandths for our American patriots, and can be used on a pitch as small as 3 millimeter. So the picture there on the left is to scale, showing EZiCoax next to a penny. So EZiCoax has a lower cost of ownership than SMP contacts. The coaxes are pressed into a plastic or metal frame referred to as an interposer, which has alignment features such as a dowel pin designed into it. It is compression mounted between two PCBs and doesn't require any solder to mate with the PCB. The interposer can be assembled on and off the PCB many times. It doesn't require any special tooling. It only requires approximately 5 ounces of force to compress, and it has no extraction force due to the nature of it being spring-loaded. The coax can absorb up to 0.25 millimeters in the z-axis, referred to as the axial direction, and it can also absorb X and Y radial misalignment up to about 0.33 if using the recommended pad layout. Interposers can also be blind mated, and the coax will not cause damage to the PCB. Spring probe arrays can also be designed into the interposer for digital signaling or power transfer. SMP style contacts, as I mentioned earlier, have a higher cost of ownership. If you have experience with SMP contacts, you can appreciate the time and labor it takes to install them. So it's a multi-step process, and it costs more to assemble than solderless spring-loaded contacts. So special tooling is required to install and remove the shrouds, and each shroud must be soldered to the opposing PCB. The residual flux should be cleaned off the PCB, which, if any of you have experience with flux, that can cause issues with contamination if other components or connectors are nearby. So the bullet is then installed on one of the shrouds using a special tool, and then the opposing PCB has to be aligned and significant force applied to the PCB to get the other shroud to mate with the bullet. So EZiCoax aligns itself to the PCB using dowel pins. Installation is quick and easy. No special tooling is required or cleaning before or post-assembly, I should say. So SMP bullets require pounds of force to assemble, and trying to disassemble the PCBs can often lead to damage due to the high demating force. So EZiCoax are spring-loaded. The only force required to install them is the spring force of the contact, which is less than 5 ounces per coax. No force is required to demate opposing PCBs, and the interposer can be removed from the board. So now we'll talk a little bit about the performance of the EZiCoax. So EZiCoax, just like the SMP contact, is a 50 ohm RF contact that can perform out to 40 gigahertz with less than 1 dB of insertion loss. Its return loss is better than 15 dB through 40 gigahertz. The near and far end crosstalk is better than minus 60 dB through 40 gigahertz. The working temperature range is minus 65 to 165 degrees Celsius, and the signal pin has a current capacity of 1 amp, and the dielectric withstanding voltage of the contact of the coax itself is 500 volts DC. So the EZiCoax has been qualified to an ESA standard, which is ESCC 3402. It's a European specification written by the European Space Agency for coax-style contacts. Some of the key highlights are 53.79 Gs of random vibration, 100 Gs of mechanical shock, which is 100 Gs half sine. So both shock and vibration repeated 3 times in each axis, so in all 3 axes. So a full qualification report is available upon request. So Smiths Interconnect performs 90% of our qualifications in our testing facility in Kansas City. And we're currently entertaining other qualifications to customer or application specific testing. So the graph to the right demonstrates the RF performance of the lowest profile contact, which has a board-to-board height of 3.3 millimeters. That's 130 thousandths of an inch. The top line in the graph represents the insertion loss of the coax, and it's measured in dB or decibels. So for those of you that aren't RF engineers, insertion loss is a measure of the attenuation or loss of the signal between 2 measurement points. Minus 1 dB equates to about 20% signal attenuation in the measurement system and is the accepted amount of loss for connectors. This means if you put a 1 volt signal in one end of the coax at minus 1 dB, only 8.8 volts would be measured at the other end of the connector. At the highest frequency, 40 gigahertz in this case, EZiCoax has negative 0.7 dB of loss, which equates to 85% of the signal transmission. The bottom line in the graph in orange represents the return loss of the coax. So return loss is a measure of the reflected signal. Signals are reflected back to the source due to impedance mismatches. So every time the signal sees an impedance change, some amount of the signal relative to the size of the impedance change is reflected back. At its highest frequency, EZiCoax has a negative 15 dB reflection coefficient, which equates to about 3.15% of the signal which is reflected. So as I mentioned earlier, EZiCoax was put to the paces, qualifying it to ESCC 3402. We are actively seeking partnerships with some of our main customers to define other qualifications to test EZ for on-wing applications and ground radar systems. So if anyone is interested in seeing the 3402 qualification report, just reach out to your nearest sales engineer for Smiths, and they can provide a copy of it. So Smiths is always striving to improve our customer service. So what we've done is we've designed some evaluation kits to demonstrate the EZiCoax performance in real-world environment. The kit demonstrates the RF performance in a real lossy environment with 6-inch traces on each side and SMA connectors, which contribute to the overall system performance. So if you're interested in seeing one of these evaluation kits, please contact your local sales engineer for Smiths to schedule an evaluation. So in the next few slides, the information presented assumes that the end user has designed their PCB to the Smiths recommended pad layout shown here on the bottom left. The recommended pad size for the center pad is 26 mils with an anti-pad size of 41 mils. So this is going to be key when looking at the next few slides when we'll talk about misalignment. So now let's dive into the effects of misalignment. So axial misalignment, as discussed earlier, is the effect of decompression of the RF contact due to the changes in board-to-board height. So what's interesting about this graph is that at the min working height, the insertion loss is right in the middle of the lines on the graph. So the insertion improves for the first 4 mils of decompression, and then it kind of flips to the other side for the last 3 mils of compression. So consequently, I mean, the difference in performance is less than a half a dB from its rate of travel. So the total amount of Z-axis tolerance that can be absorbed is 8 mils, roughly 0.2 millimeters, between the min and max working height of the smallest EZiCoax. So the performance drops just below -1 dB point at the max board height, 1.38 inches, which is 3.5 millimeters. So the radial misalignment occurs when the boards are not aligned in the X and Y direction. So as can be seen from the graph, the performance doesn't change much when misaligned in the X and Y direction. Again, this is dictated by the pad size and anti-pad size of the PCB. So just to reiterate, we recommend 26 mils for that center pad with 41 mils for the anti-pad. So as long as the EZiCoax hits the pad, it will perform. If there's less than half a dB shift in the insertion loss, with plus or minus 10 mils or 0.25 millimeters of mismatch in each direction. So angular misalignment occurs when there's both axial and radial misalignment. In the 3-piece SMP, this occurs because of shroud alignment between the PCBs. So interposers are unique in that they are designed for the for the PCBs to be flush mounted against the interposer, which aids in keeping them parallel to each other. But if angular misalignment does occur, there could be up to 2.5 degrees of displacement before you approach that -1 dB of loss. So in the next couple of slides, we'll show the initial 4 sizes of EZiCoax. The first is the lowest profile version, which has the minimum working height of 130 mils, just over 3 millimeters. And then it has a working range from there of 8 mils. So the min working height in the case of EZiCoax is really that max compression. And then the max working height is what's considered to be the min compression or the min tolerance of the boards to each other. So the outer barrel of the coax has a bulge feature called a press ring, kind of indicated by the arrow there. This is what retains the coax in the interposer once it's pressed into the housing. The coax diameter is optimized so the coax can be used on pitches of 3 millimeter centers, roughly 120 mils or greater. So the next size up has a maximum working height of 268. I'm sorry, I said that wrong. It's minimum working height of 268 up to 280 mils. So in metric, that's 6.81 millimeters up to 7.11 millimeters. All of the coaxes in the different sizes have the same diameter and can be used on the same pitch. So the next coax size has a working range of 467 mils to 479 mils. That's 11.86 millimeters up to 12.17. The longest version will have a board-to-board working range of 712 mils to 724 mils. That's 18.08 up to 18.39 millimeters. All 4 ranges will have complementary spring probes designed. So in the center contact of the EZiCoax is a spring pin. That same spring pin can be used for design into interposers for digital, mixed signal, and power applications. So there's a lot that you can do with spring probes when it comes to RF and power. So now what I'll do is I'm going to pass the webinar over to Kyle to provide more context on Interposer Solutions and their applications. So Kyle, over to you.
Thanks, Kevin. Hello, everyone. So, Smiths Interconnect has a long heritage of building compliant contact connectors. So next we're going to talk about these types of interposer solutions. The definition of an interposer is an electrical interface routing between one socket or connection to another. Interposer connectors work by bringing into connection two opposing sides of a printed circuit board. The housings are typically in engineered plastic of some sort, Tecapeak and Altums. However, depending on the environmental or electrical performance needs, many other materials can be used. Most interposer designs start out as a machine solution for prototyping purposes. And depending on the production volumes or design characteristics, molding also will come into play, especially if there are environmental sealing considerations to be aware of. What we're showing on the right is a generic example illustrating several different features and layouts that can be incorporated into your interposer solution. The purpose of these features allow for us to design with explicit focus on optimizing for signal performance or to fit specific space constraints within a system, or just increase the ease of installation or system reworkability. Things that can be incorporated easily into the interposer design are dowel pins or bosses on the plastic housings for alignment, through holes, and hardware for securing and mounting purposes, and specialty cutouts to avoid other system level components that already exist, and even environmental or EMI gaskets can be designed in. Impedance matched differential pair signals can also be passed in a tight grid array, as well as a typical I/O and power signals in pretty much any pattern imaginable. These arrays and patterns can range in heights from around 3 millimeters up to well over 25 millimeters, and typical pitches getting down to as small as 1 millimeter in some cases. For example, RF signals can be passed by utilizing an individual spring probe centered around a grouping of other probes connected as the ground shield. You see that up in the top right, which we call this a gallon shooter array. An additional way to pass RF signals, especially in a ganged array, would be to utilize what we refer to as a standalone coaxial approach, where a probe is pressed into a standalone dielectric, then inserted into a typically metallized and grounded housing. This approach is commonly used when passing many RF signals through a small common space. However, a better alternative for this and the Gatlin shooter array today is our new EZiCoax. So EZiCoax would not require the grounding housing, and its outer plunger is already incorporated into the design. It would also require less space than both solutions. For those interested in standard configurations, 2, 4, and 8-way solutions will become available with EZiCoax contact. As Kevin mentioned earlier, we have developed a test kit for EZiCoax that customers can use to demonstrate the performance and bench test potential applications. So EZiCoax primarily targets the space and military markets that are interested in increasing the ease of installation or system reworkability while maximizing performance and ruggedness. Anywhere you currently use coax cables, SMPs, 6 and 4 gang shooters, or just general board-to-board connectors for RF could be replaced with the EZiCoax probe. In comparison to EZiCoax, SMPs are not solderless. They have a high cost of ownership and high insertion removal forces. 7 and 5 Gatlin shooter arrays require more interposer space, and cabling is bulky, and their elimination can result to up to 90% of weight savings. In the bottom right, you can see an example of a multi-input and multiple output, or MIMO architecture. The MIMO technology uses multiple antennas to transmit and receive the same signal. In this type of architecture, there's multiple stack-ups of chassis and antenna arrays. Currently, one set of connectors is defined as 2 male and 1 female to female barrel. However, with the EZiCoax, these 3 connectors can be replaced with 1 contact, eliminating soldering, easily facilitating rework, and bench testing or qualification of individual systems. For space applications, consist of satellites and deep space probes and rovers, which include antenna systems such as high throughput communication satellites, antennas, and scientific instrumentation. Launch vehicles encompassing areas such as avionics, telemetry modules, and separation systems as well. On the military side, active electronically scanned arrays and radar systems are common applications. So on this slide, I'm going to tell you about RF frequencies and how they correlate with the different applications. So EZiCoax is currently rated for frequencies from DC up to 40 gigahertz. However, most applications will likely fall within the ultra super and high frequency ranges. Ultra high frequency starts at 300 megahertz up to 3 gigahertz. So common applications in this frequency band are Wi-Fi, Bluetooth, sat-nav, and mobile phone networks. Super high frequency encompasses 3 to 30 gigahertz. So common applications here are SATCOM, radar systems, and mid-band 5G. So again, Wi-Fi, such as your household 2.4 gigahertz and your 5 gigahertz dual band and tri-band routers fit within this category. Finally, extremely high frequency covers 30 to 300 gigahertz. So again, since our EZiCoaxial Spring probe is only rated up to 40 gigahertz, we're only covering relevant frequencies within the span today. So EHF is your ultra-high speed communication networks. This is your millimeter wave 5G networks and your K-band satellite communications and radar systems. I will not go through all the IEEE and NATO bands today, since that would probably require its own webinar series to cover, but I've listed a few in the bottom right table as a reference. And now I'll hand it back to Kevin.
Yeah, thank you, Kyle. So just kind of summarize. So EZiCoax is a RF contact that kind of replaces traditional solder SMP contacts. So it's our response, our Smiths Interconnect's response to the need for high reliability solderless SMP connectors, which meet the electrical performance of the solder style SMPs. So EZiCoax can be integrated into interposers with power and signal contacts to address mixed signal requirements. The lowest profile is 3.25 millimeters, roughly 130 thousandths of an inch, to be used on pitches as small as 3 millimeter centers, has a lower cost of ownership than SMP solder style contacts, and can be integrated into mixed signal applications. The contacts have been qualified to ESCC 3402 and have an operating temperature of minus 65 to 165 degrees. So at this point, I'm going to pass the baton back to Katie, and we're going to take a small break to allow for more questions. Katie, back to you.
Great. Thank you guys both so much. So Kevin and Kyle, appreciate the great presentation. So we're going to move into our live Q&A session at this time. So Kevin, you did address a couple of the questions that came into the queue, just a couple of people asking about the 4G or 40G. So just wanted to address those since there are a few in there. So I know that we've kind of touched on those, but anything else you'd want to go over with that, Kevin?
So to be specific, this is an RF contact, so it's 40 gigahertz. So typically when you say something like 4G or 5G, as Kyle alluded to, you're referring to more of digital signals. Just looking at, the fundamental frequency, you could definitely push EZiCoax to above 56 gigabits of NRZ for those types of applications.
All right. Thank you so much for clarifying, Kevin. So we have some more questions that have popped in the queue here. This person is asking, are there any plans to design a solderless board to cable rather than board-to-board solution? And then explaining, we often need to bring groups of 16 coax connection off a board and into coax cables to move the signals elsewhere. EZiCoax would greatly reduce the size of the board footprint needed if you had a way to transition into cable. So this is from Chad. So Kevin, anything on that?
Yeah, so kind of the roadmap right now for EZiCoax, we're going to come out with the initial board-to-board or straight, what we call the straight version, which will sit between two boards. The next step in the evolution is to develop a right angle, which is already in motion. And then definitely part of the evolution of EZiCoax would be to address flyover type technologies. So, again, if that's something that you want to discuss further, I would suggest reaching out to a Smith sales engineer and, to get that conversation started. But yes, it is on our roadmap.
All right. Thank you so much, Kevin, for that answer. So next one here, how many mating cycles can the EZiCoax achieve?
So the EZiCoax, during qualification, we rated it for 1,000. That was just a number that we picked. Typically 500 mating cycles is what most connector technologies are tested to.
All right, thank you for that. So next one here in the queue, where will the product be assembled?
So all of the assembly for EZiCoax will be done in our Kansas City manufacturing location. So Smiths has invested well over £1 million to completely automate the assembly of it. So the automation piece will have positive laminar flow for clean room style assembly, and then each coax will be tested during the assembly of the coax. So yeah, definitely Kansas City, definitely going to be built in America, and then shipped all over the world. So we have we have our locations located in Italy. We have locations in France, and then locations in the UK. So they will typically be developing any Interposer Solutions for overseas, and the contacts will come from Kansas City.
All right. So next one here, which PCB finish is recommended for EZiCoax contact assembly?
So we would recommend Interpig. Typically, it's a very common plating for printed circuit boards, and the qualification was done with Interpig. Other than Interpig, we would typically recommend 1.27 millimeters of microns, not millimeters. That'd be a lot of gold. 1.27 microns of gold to prevent, if you're going to go through any type of environmental qualification with the contacts, or if they're going to be used in harsh environments. But like I said, the ESCC 3402 has all of the environmentals in it, and we used Interpig. It's electroless nickel, electroless palladium, and then immersion gold is what Interpig stands for.
All right. Thank you so much, Kevin. So next one here, this person's asking, is insertion and return loss data available above 4 gigahertz?
Yeah. So again, if you reach out, so the data is available all the way up to 40 gigahertz. So you can obtain that by just contacting your Smith's Interconnect sales engineer, and they can provide that.
Great, great. Thank you for that, Kevin. All right, looking here. Will the contact ever be sold individually? Will it be sold direct or only through distribution?
So, so there's definitely plans for it to be sold through distribution eventually. So we want to make sure that we control the narrative of how it is developed into applications in the beginning, and then once we get more and more application data for it, then we will release an application guide and probably offer the contact in individual contacts. But for now, it's going to be offered only in Interposer type solutions.
All right, Kevin, thank you for that. All right, Kevin, next one here. Does EZiCoax have space heritage?
So that's one of the reasons, that we chose ESCC 3402 for the qualification. That is a qualification that was designed by the European Space Agency. So, other connectors would see the ESCC 3401 type qualification, and we also have connectors that are qualified to that specification as well. We are, we are working with some customers on their individual qualifications. Typically, the main concern is around, operation for like on wing or ground applications where the connectors are going to see different profiles of shock and vibration. So we're working with customers now to develop those.
Right. Thank you so much for that. All right. Next one here. How do I get a sales kit to evaluate the performance of the EZiCoax?
Yeah. So if you reach out to your Smiths Interconnect sales engineer, they can provide them. The kits themselves are very expensive, as you can appreciate with with high speed SMB style connectors on them, and there's, I believe, if I remember correctly, there's a total of 16, either 16 or 20 of those connectors on each board. So they're very expensive, very coveted. So I would say reach out to your Smiths Interconnect sales engineer to schedule an evaluation.
Right. Thank you so much for that answer. So we are getting close to the top of the hour here. So I'm going to ask if anybody has any last minute questions.
So yeah, there is one in there that I think came in at the last minute for the asking about the planar edge mount. I assume that means right angle, if I'm not mistaken. So yes, that is the next evolution. We're qualifying the intermediate sizes of the coax. We've taken the smallest coax through qualification, and then the next step would be to take the right angle version, which has already been designed, take it through qualification. So it'll be available, a few months after the product is launched, which is at the end of this month.
Right, Kevin, thank you so much for grabbing that last question out of the queue that popped in. So we are getting to the top of the hour. We're going to wrap things up right now. So before we do that, I want to say a huge thank you to Kevin and Kyle for a great presentation and for answering some of the attendees' questions. So gentlemen, thank you both so much.
All right. Thank you all.
Thank you, Katie.
So I want to say one more time, thank you all for attending today's event. Take care, and we will speak with all of you soon.